We are on day 2 of Chapter 2 review, and today we are working in self-test. All right, starting with number 1, some basic simplifying, combining like terms. 5w minus 2w, both have the same variable, so you just combine the coefficients, so it's 5 minus 2, and that's 3w. Number 2, we got to deal with a fraction. Now, if you wanted to, before you multiply by the 6/7, you could put these together. They're inside parentheses, and you have a v and you have a v. So you could potentially do that, and then you won't have to combine fractions later. So I'm going to go ahead and do that. You didn't have to. You could have distributed by 6/7, and then you would have had two terms that had v's on it, probably fractions because you multiplied by 6/7, and then you'd have to combine those. So you'd be combining fractions. So just looking ahead, I'm going to save myself the step of having to multiply by a fraction and then add two fractions together. You're still going to get the same answer. Okay, but I'm just going to go ahead and simplify this. So 3v and v to go together to make a 4v plus 78. And now I can distribute the 6/7. Again, on the calculator, you hit the green alpha button and then you hit the X button next to it. 6/7 times 4. You can get 24/7. So it's 24v/7. And then we're going to go ahead and distribute the 6/7 here. So alpha x 6/7 times 78. And you get 468/7. Now, neither one of those is going to divide nicely by 7. The calculator would have already simplified if it could. So we're leaving it just like this, fully simplified. Since they have the same denominator, we're going to go ahead and combine them. So it's 24v plus 468/7. Okay, number 3. We've got some distributing to do before we do anything with this -7h, so I'm going to leave that alone. Distributing, this is a positive 2, so 2 times h, that's positive, so I write plus 2h. Now, 2 times -4 is a negative, so I write minus 8. Now all I got to do is combine my like terms. The 8 doesn't have anything to go with, but the h's can go together, so -7 plus 2 is -5h minus 8. Number 4. So this is one where we have the subtraction of an entire quantity, meaning subtracting everything here in parentheses. And what we have to do to properly do this is subtract both terms. So we distribute the negative or the minus sign as a -1. So everything up front is going to stay the same, although I can distribute. So let's go ahead and distribute. So 3k plus 30. Now this gets distributed as a -1. So it's -1 times 11, that's -11, so I write minus 11. And like I've been harping on, this is the part where people mess up their sign. This is a negative times negative, so it's positive. I write plus 4k. There was no number to multiply by. I'm just changing the sign. Basically, it's the opposite of 11. That's -11. The opposite of -4 is +4. Now I can combine some like terms. So I'm going to go ahead and make this 7k. And then 30 minus 11 is positive 19. All right, number 5, just simplifying here with a bunch of negatives. For every 2 negatives, they cancel out. So I have 1 left over because there was 3. An odd number of negatives will remain negative, so the answer here is just -r. All right, and then some fractions here, but with a common denominator. We can go ahead and write all of this over 6, and in the process we can combine these. Now we do need to be careful. If this was a minus, you'd have to write it out like this one up here, and you'd have to distribute the negative. But it's a plus. So they're just going to go together. So the 2x and the 5x will be 7x plus 7. All of it over the same denominator of 6. If 7 could be divided by 6 nicely, like let's say it was a 12 over 6, then you would split this back into two pieces and simplify either both fractions or one of the fractions that is divisible by 6. But neither one of these, if I split them up, it's still going to stay 7 over 6 and 7 over 6. They're not going to simplify. So there's no need to split them up, and you can leave it just like this. All right, so on number 10, if 2 times n equals 4, I'm going to write that as 2n equals 4. Then, if you have 2n times 6, I'm going to write it like this. A little bit different order, but I have 2n times 6. What does it equal over here? That's the question. So what I want you to notice is 2n is here, and 2n is here. 2 times n and 2 times n. And so they're testing your knowledge of the equality properties. If you do something to one side of your equation, to the left or to the right of the equal sign, as long as you do it to the other side, they remain equal. So we have the 2n, we're multiplying it by 6. So to maintain equality here, I also have to multiply this side by 6. Well, this side was a 4. And so you could actually leave it like this, but they've fully simplified their answer here. 4 times 6 would get you a 24 on that side. So if 2n equals 4 and you multiply by 6 on the left side, you got to multiply by 6 on the right side, and there's your 24. Okay, number 11, write the related facts for c equals pi times d, and then they tell you what these represent. So this is an actual formula that we'll come back to and use when we're talking about circles. But we're just going to go ahead and basically make a fact triangle. You don't have to make the triangle, but they want you to write the related facts. So sometimes it's easier just to write the triangle out first. So this is a multiplication fact triangle. You can see that pi and d are getting multiplied. Even if you have no idea what pi is, it doesn't matter. You know those are multiplications, so you're going to put that and the d on the bottom. They're being multiplied. And then we read division from the top down, so c goes on the top. So even if you have no idea what these represent, it doesn't even matter. The two things being multiplied, whether they're letters or numbers, will be down here, and then the division works from top down. So we already have c equals pi times diameter, so that's that direction. So the next one, you could leave it as c equals, and then just change the order of your multiplication, d times pi. And then the third and the fourth, you have to show your division, so you're reading from top to bottom. So you're doing c divided by d equals pi, and then also c divided by pi equals d. And now since this is an actual formula, circumference equals pi times diameter. Circumference is like the perimeter of a circle. If you were looking for one of these things specifically, if you were looking for circumference, you would want to use one of these two formulas because it's isolated. We would never really use this one. But here, if we wanted to find the diameter and we were given circumference, we would want to use this formula. You would take the circumference divided by pi, and it'll give you the diameter. Okay, so each one is useful in its own way, and we'll get much more into that farther down the road. All right, after number 11, we jump to 13. Another fact triangle. This one's with addition. Addition goes across the bottom, subtraction from top down. So since these are being added, I'm going to put those at the bottom. And negative 12 goes up top. So I've already got them added this direction. That means I could write it again, but with these flipped, so negative 8 plus negative 4. So now I have both addition problems. I need both subtraction problems. Reading from the top down, negative 12 minus negative 8 equals negative 4. And negative 12 go the other direction, minus negative 4 equals negative 8. And if you were actually going to go through and do the work, you could go plus plus, minus a negative turns to plus plus. Negative 12 plus 8 is negative 4. Same thing as negative 12 minus negative 8. All right, so those are your related facts there. 14. Find the opposite. So opposites are easy. That's just the positive and negative versions. They add up to 0. So if I have negative 3p, what do I add to negative 3p to get 0? The opposite Negative 3p is just positive 3p. And 15, I've got b plus 2 to start with. I need the opposite of this, so negative b plus 2. Now this is correct, but we would simplify it. So you would distribute the negative, and so you get negative b minus 2. You can't just put it on the b. It also has to go to the 2. So it's negative b minus 2. And then 17, the other word that we use a lot here, reciprocal. And that's the number that when you multiply, you get 1. And that's just the flipped version of the fraction. You can see on 17, it's already a fraction, so we don't have to do anything with it except flip it. So the reciprocal of this, put the 11d on top, put the 4 on the bottom. And again, the reason is if I multiply across the top and across the bottom, I'm going to get the same thing on the top and the bottom, which means my answer is 1. Okay, 19, I'm going to squeeze that one in here. One of these number puzzles, we're starting with n. Let n be your number. We're going to use algebra to show how this works. So multiply by 10, that's 10n. Add 30, that's 10n plus 30. Now don't call this 40n. We didn't add 40 times the number. We just added 30, not a like term to an n, so you leave it separate. Divide by 5. All of this gets divided by 5, each piece. If you wanted to actually show it, it looks like this, and you could actually split it into 2 pieces, but 10 divided by 5 and 30 divided by 5, so both of them there. So I'm going to get 2n plus 6, both of them divided by 5. Subtract your original number. The original number was n, so I'm minusing n. That comes off of here. So a 2n minus a 1n is just an n. I still have plus 6. It was not affected because it's not a like term. Then we're going to add 1. And that makes this a 7. Does not affect the n because it's not a like term. So I have n plus 7. And then subtract 7. Well, if I subtract 7, this comes off, and I'm left with n, which is what I started with. And it says you should have your original number. And we do because we got n. So we're all set. Okay, next up was number 21. So it says use properties of operations to determine whether these two big, well, this is a big one and this is a small, expression are equivalent. So you can do this pretty much any way that you want. You could make a table. You could technically put this on a graph and see if they're the same. And you can also simplify, and that's the way that I'm going to do it. So I already have 6w minus 5. I noticed that one's already fully simplified. So really all I got to do is take this other one and instead of plugging numbers into this and plugging numbers into this, that sounds like a lot of work. Because remember, you can't just plug one number in. You probably want to try a positive, a 0, and a negative to prove that it's truly equivalent. So I would much rather simplify this one and see if I get the equivalent expression to this. And so I'm going to go ahead and do my distributing here. Everything else comes down. This parentheses here doesn't need to stay. Technically, a 1 gets distributed. Looks like this. 2w, 3w, and a 1w. 1 plus 2 plus 3, that's 6. A negative 1 and a positive 18. So 1 comes off at 18, that is 17. Sorry, this w stays there. And so this one and this one, they don't match. So these are not equivalent. And 23, now they want you to specifically make a table to show that these are not equivalent. So when you make a table, you need both expressions represented. Absolute value of negative 2x minus 1. And what you do is you put x here on the first one, and that's just the number that you're choosing. We've talked about positives, 0, negatives. You want to test all of them out. So I'm going to start with some positives, take 2 and 1, and do 0. And then we'll go to some negatives. And that's as far as you really need to go. So plugging in 2, 2 times 2 is 4, plus 1 is 5. Plug into here, negative 2 times 2 would be negative 4, minus 1 would be negative 5, and the absolute value makes it positive 5 at the end. Remember, the absolute value doesn't do anything until you've already got your value, and it makes it positive. So far they look equivalent. Plug in 1. 2 times 1, that's 2, plus 1, that's 3. Over here, negative 2 times 1, that's negative 2. Minus 1 is negative 3. Absolute value makes it positive 3. Plug in 0. 2 times 0 is 0, plus 1 is 1. Plug in 0, you multiply, 0 minus 1 is negative 1. Absolute value makes it positive 1. So right now we're looking like these are equivalent. And plug in negative 1. So 2 times negative 1 is negative 2, plus 1, that's negative 1. Negative 1 times negative 2, that's a positive 2, minus 1, that's 1. Absolute value is 1. Uh-oh, we got a problem. That didn't work. Now, I wouldn't stop there because maybe I just made a silly mistake. So before I claim, oh, these aren't equivalent, let me try one more negative number and see what happens. So I plug in negative 2. 2 times negative 2 is negative 4, plus 1, that's negative 3. Plug in negative. It's negative 2 times negative 2, that's positive 4 minus 1 is 3. Absolute value is positive 3. Again, you can see this. These are not equivalent. And they actually told you that here. They said make a table to show that they are not equivalent. So we should have already known they were not equivalent based on just the wording of the question. But this is how you prove it. So all positive numbers are going to work. 0 is going to work, but our negative numbers are a counter example to this. And we're going to take a look at a couple more questions similar to this. We jumped over to page 127. And we're looking at 60. So this is on page 127, 62 to 64. So on 62, we're going to do the same thing we just did. We're going to show using a table. So if I was given options here, I would just simplify. But they specifically want you to make a table. They want to see if you have that skill. So you're going to put the number that you're choosing here. This is 62. You're going to do 3 times 2x plus 4 in your first column, and then 6x plus x plus 12 minus x in your third column, and we're going to prove that these are equivalent. It's telling you they're equivalent. We're going to show it here. So let's go with a 2, a 1, 0, a negative 1, and a negative 2. You don't necessarily have to do that much. So let's plug in 2. 2 times 2 is 4 plus 4 is 8 times 3 is 24. Plug in 2. 6 times 2, that's 12, plus 2 is 14, plus 12 is 26, minus 2 is 24. So that worked. I'm going to go to 0 now. 2 times 0 is 0, plus 4 is 4 times 3 is 12. This would be 0, 0, 0, and you still have 12. So that's looking good. Let's do negative 2. So plug in negative 2. 2 times negative 2, that's negative 4. Plus 4 is 0, and 3 times 0 is 0. So we should get a 0 here. So 6 times negative 2, that's negative 12, plus negative 2, plus 12, minus negative 2. So we're going from left to right here. Negative 2, 12 plus negative 2, that's negative 14, plus 12, that's going to be negative 2, minus negative 2, goes plus plus, negative 2 plus 2, and that's 0. Okay, so we used a positive, a 0, a negative. We've shown that they are equivalent. Okay, 63, again, make a table to show that x squared and 2x are not equivalent. So that's super easy. X squared, 2x. Let's go with a 2, a 0, and a negative 2. 2 squared is 4. 2 times 2 is 4. 0 squared is 0. 2 times 0 0. So these look equivalent so far, but here comes the negatives. You plug in negative 2 squared. Negative 2 times negative 2 is positive 4. Plug in negative 2. Negative 2 times 2, that's a negative times a positive, it's negative 4. Okay, so we've made a table to show that they're not equivalent, and you want to circle a counterexample. The counterexample is the one that proves that it's not true. That would be right there. And 64, we don't have to make the table. It's done for us. We don't even know what the expressions are. We're just analyzing the values that we've gotten here. Do the expressions seem to be equivalent? Why or why not? So here's expression 1. Look at the numbers. We plug in these x's, and we get these y's. And on expression number 2, if you notice, they plugged in the same x values. So just like we plug in the same x values to both expressions, that's basically what they've done here without showing you the expression. And then we want to check out, well, what was the results? So for negative 5, on this expression, we got negative 4. And on this expression for negative 5, we got positive 4. So negative 2, positive 2. And then you can see down here that we did get the same answers, but up here we did not. So to answer the question, do the expressions appear to be equivalent? No, not equivalent. And it does say why or why not. So you want to explain. For the x values, negative 5 and negative 4, the results were different. Or something along those lines. Answer key said they're not equivalent. The values for negative 5 and negative 4 are different for each expression. So however you explain it in your own words, we just have to notice that similar inputs of negative 5 and negative 4 produced different outputs, negatives here, positives here.